Good day, everyone. This is the second part of the discussion for the topic Functions, Relations, and Functions as Models. In the previous discussion, we defined a function mathematically, which is a special type of relation such that no two distinct members have the same first element. But how do we use the word function in the English language? We have here function as corresponds to and function as depends on. Example for corresponds to each person there corresponds an age. To each item in store, there corresponds a price. To each automobile, there corresponds a license plate number. And to each particular circle, there corresponds an area. Let's have function as depends on. What causes tsunami? We know that an earthquake is the cause of tsunami. When the magnitude is higher, the tsunami will be severe. And if the magnitude of the earthquake is lower, then the tsunami's effect will decrease. So tsunami's force depends on the magnitude of earthquake. Let's have another example. What causes flood? How does rainfall affects the level of flood? What happens if rainfall increases or decreases? We know that the level of rainfall or the amount of rainfall causes a flood. So therefore, flood's level depends on the amount of rainfall. Let's have function as machine. Here we have a picture of a machine. We have here in, we put anything we want to enter here, and then there's a rule, which is the process the machine will do to whatever we put inside to have the output intended. For example, we want to put 60, and the rule is to multiply by 10, so we will have an output of 600. Let's have another example. Let's have the rule f of x is equal to 2x minus 5. We want to input 10, so we process it inside 2 times 10 minus 5, and that will give us 15. Another one, if we want to put negative 2, we process it inside 2 times negative 2 is negative 4 minus 5, so that will give us an output of negative 9. So 10 and negative 2 are your domains, and 15 and negative 9 are your range. So this is how we illustrate function as a machine. Functions can be used to model real-life situations. Identifying an appropriate functional model will lead to a better understanding of various phenomena. We have here a juicer machine. If we put an apple, we will have an apple juice. We don't expect otherwise, like an orange juice, since we put an apple. Let us apply the mathematical concept of function in situational problems. Let's have situation number 1. STEM 11A students list down their grades in general mathematics. Basically, each student has only one grade for Gen Math, but more than one student can get the same grade. Let us illustrate it through mapping diagram. So we have here Ashley got 97, Kate 93, Jerlyn 95, Apple 92, and Mark also got 92. Set A is the name of students, which is your domain or inputs. And set B is the list of general mathematics grade, which is your output or the range. Now this, as illustrated, the problem represents a function, since no element in set A is paired to more than one element in B. Here are the questions to ponder for situation number 1. Is it logical that each student gets only one grade? Of course. No students can get 2 grades in one subject. Can we consider this an example of a function? It is also a yes. Number 2, is it also logical that more than one, say for example 3, can get the same grades as the others? As illustrated in the example earlier, we have it there, Mark and Apple they have the same grade, which is 92. So this is still a function since the correspondence is many to one. Okay, two students with the same grade. Okay, number 3. What function model will represent the function situation as x be the name of the student and y be the grades of students? Okay, so we can have here y is equal to x since for every student there corresponds a grade. So let's have situation number 2. In our canteen, all kinds of juices are worth 5 pesos each cup. There is buko juice, pineapple juice, chocolate juice, mango juice, and many more to choose from. Enzo wants to buy 2 different juices while Andre wants to buy 3 different juices. So let us represent this one or illustrate this one using mapping diagram or arrow diagram. So we have here for set A, you have the number of juice flavors that you're going to buy, and for set B, you have the price that you're going to pay. So if you bought 1 cup, so you will pay 5 pesos, and if you bought 4 cups, you will pay 20 pesos, and so on and so forth. Now, okay, so now here's the question to ponder for situation number 2. Can we consider the relation between the total price of what Andre and Enzo will pay to the number of juices that they are going to buy a function? So the answer here is yes. Okay, for whatever number of cups that you're going to buy, so there is a corresponding amount that you're going to pay. And then, will the total amount of payment be your input or your output? Since we are asked to find the total amount, so this is your output. Okay? And number 3, will the total number of juices they want to buy be your input or output? So this time, this is your input. Now, how will you represent it as a function model? So since for every cup, it is you pay 5 pesos. For 2 cups, you pay 10 pesos. So if you will examine the output, so this we simply substitute or multiply the number of cups to 5 pesos. So you will have here y is equal to 5x. So that will be your function model. Okay, let's have the last example. Situation number 3. A grade 11 students who decided to ride a tricycle going home from school noticed a table of fares posted inside the vehicle. He read the fare guide during the trip and found out that he needed to pay 10 pesos as the basic fare that covers a 5-kilometer ride and an additional of 1 peso every succeeding kilometer. So for 5 kilometers or less, you will pay 10 pesos, and then for additional 1 kilometer, for every additional kilometer, they will add 1 peso. So illustrating it using mapping diagram, so we have here for 3 kilometers, you're going to pay 10 pesos. For 5 kilometers, still you're going to pay 10 pesos. But if you cover 6 kilometers, so that will give you 10 pesos plus the additional 1 kilometer, which is 1 peso, so you will have 11 pesos. And then this one is 7 kilometers, so you will have 5 kilometers, the first 5 is 10 pesos still, plus the 2 exceeding kilometer, that is times 1 peso, so you will have 12 pesos. And then for 8 kilometers, you're going to pay 13 pesos. So for the set A, that is the distance in kilometers, and for set B, that is the tricycle fare. Okay. So here are the questions to ponder for situation number 3. What have you noticed? Did you find the situation given different from the previous 2 situations? So they are different from the previous 2 examples because the third example has more than one condition. Okay, number 2, what seems different? Okay, the possible input are divided into pieces. Can we still consider the situation a function? Yes, it is still a function. It is called a piecewise function. How will you represent it as a function model? For example, let k be the total kilometer ride and t of k as the total fare. So your k there will be your input, so the number, and that is t of k, but that will be your output. Okay, so k represents the kilometer and t of k will represent the total amount of fare. So we can write it this way. So 10 pesos for k less than or equal to 5, meaning if you cover 5 kilometers or less, you will only pay 10 pesos. Now, for if you cover more than or greater than 5 kilometers, so you will have here 10 pesos plus k minus 5. For instance, in the example, if you cover 7 kilometers, so that will be 7 minus 5, you will have 2. So the additional amount to pay is 2 pesos plus the 10 pesos for the first 5 kilometers. So here are the questions to ponder for situation number 3. What have you noticed? Did you find the situation given different from the previous two situations? So they are different from the previous two examples because the third example has more than one condition. Okay, number 2, what seems different? Okay, the possible input are divided into pieces. Can we still consider the situation a function? Yes, it is still a function. It is called a piecewise function. How will you represent it as a function model? For example, let k be the total kilometer ride and t of k as the total fare. So your k there will be your input, so the number, and that is t of k, but that will be your output. Okay, so k represents the kilometer and t of k will represent the total amount of fare. So we can write it this way. So 10 pesos for k less than or equal to 5, meaning if you cover 5 kilometers or less, you will only pay 10 pesos. Now, for if you cover more than or greater than 5 kilometers, so you will have here 10 pesos plus k minus 5. For instance, in the example, if you cover 7 kilometers, so that will be 7 minus 5, you will have 2. So the additional amount to pay is 2 pesos plus the 10 pesos for the first 5 kilometers. Function can be defined using different equations on a disjoint subset of its domain. Disjoint meaning separated. A function defined this way is called a piecewise defined function or simply piecewise function. Okay. A piecewise defined function or simply a piecewise function is a function that is defined by two or more equations over a specified domain. So you have there two or more equations. Just like problem or situation number 3. So there are two equations there, and then over a specified domain, so you have also there two domains. One is for k less than or equal to 5, and the other one is k greater than 5. So you have two inputs for two specific equations. An example of a piecewise function that you have learned in your junior mathematics is the absolute value function. It is represented by the equation f of x is equal to the absolute value of x. So using piecewise defined function, we can write it this way. So you have f of x is equal to an open brace, and then you write the two equations. So here we have two equations. You have here x, if x is greater than 0, so you will have a positive input. And then if you will have x is less than 0, you will have a negative input, but your output will still be positive since it is an absolute value equation. So you have two equations with different domains or input. One is positive and one is negative. Let us evaluate a piecewise function. For example, if f of x is equal to 2x plus 1 if x is less than or equal to 0, and negative x squared plus 1 if x is greater than 0. So we have here two equations, 2x plus 1, the domain is less than or equal to 0. So all numbers less than or equal to 0. While for equation x squared plus 1, we have here the domain is greater than 0, meaning those numbers that are positive. For this one, those numbers that are negative, including 0. So if we are asked to find f of negative 7 is less than 0, so we will be using the first equation, 2x plus 1. And then we just substitute it, the negative 7 to the x, so you will have 2 times negative 7 plus 1, that will give you negative 14 plus 1, and that will give you negative 13. So therefore, if x is negative 7, your y is negative 13. Okay, let's have another example. Let's find f of 5. So since f of 5 is greater than 0, so we will be using the second equation. So you will have negative x squared plus 1. Again, substitute. Here, 5, the value of x is positive 5. So we will enclose only the positive 5 to the parentheses, and then we have it 5 squared, that will be positive 25, times the negative outside, that will give you negative 25 plus 1. So f of 5 is equal to negative 24. So this will be your final answer. This is how you evaluate a piecewise function. Okay, let's have application problem number 1. Big Bytes Computer Shop charges 30 pesos for the first 4 hours of renting a computer. It charges 10 pesos for each additional hour or a fraction thereof. You are asked to find or construct a function A for the amount charges for each hours of computer rental. So this is an example of a piecewise function. There are two conditions. One is for the first 4 hours, it charges 30 pesos. And then for the additional hours, that will be 10 pesos per each hour or a fraction of thereof. In meaning, if you only play for additional 30 minutes, you still have to multiply it by 10. So let's represent, since we are looking for the amount charges, your A here will be your output and H will be your input. So representing it using the piecewise function, we will have it this way. So we have 30 pesos. If hours, or the number of hours, is greater than 0, meaning if you consume 30 minutes only, that is still 30 pesos. Or it is greater than or equal to 4. So this is how you read it. Hours is greater than 0 but less than or equal to 4. So that will be equal to 30 pesos because that is the price for the first 4 hours. Now, it charges 10 pesos. So if you for example, you play for more than 4 hours, for instance 5 hours, so the excess hour will be multiplied by 10. So that will give you, so we have here h minus 4, the first 4 hours, multiplied by 10 plus 30 if the number of hours is greater than 4. So this is the piecewise function for this problem. Okay. A follow-up question: if Andrew entered the shop at 11:30 a.m. and played video games until 5 p.m., how much will he pay for the use of the computer? So here, using the piecewise function, the number of hours he played is not yet given, but the time he started and stopped playing is given. So we have here from 11:30 to 5 p.m. So we just count the number of hours from 11:30 to 5. So after an hour, 12:30, that will be the start of the 1 hour. So you will have here 12:30 is the first hour, 1:30, 2:30, 3:30, 4:30. And he stopped at 5 o'clock. So from 4:30 to 5 o'clock, you only have half an hour. So counting that one, we will have here, he played for 5.5 hours or 5.5 hours. And since 5.5 hours is greater than 4, so we will be using the second formula. So substitute nyo lang siya doon. You will have here 30 plus 10 times 5.5 hours, the number of hours he played, minus 4. So we have to subtract all at 8 to 4 because the first 4 hours will be 30 pesos. So subtract that one, that will give you 1.5, that is the extra hour, multiplied by 10, so that will give you 15 pesos. So for 5.5 hours, he will pay 45 pesos. So that's how you solve it. Let's have this problem. A Zumba instructor charges according to the number of participants. If there are 15 participants or below, the instructor charges 500 pesos for each participant per month. If the number of participants is between 15 and 30, he charges 400 pesos for each participant per month. And if there are 30 participants or more, he charges 350 pesos for each participant per month. So write the piecewise function that describes what the instructor charges. Okay, so for this given, we have here three conditions. The first condition is the participant or the instructor will ask them to pay for 500 pesos each for 15 participants and below. And then they will pay 400 pesos each if the number of participants is between 15 and 30. And he will only ask them to pay for 350 pesos if there are 30 participants or more. So what will be the piecewise function for this? So first, let us represent the input and the output. So we will have here, since we are looking for the charge, so that will be your output. So let's have C for the charge and P for the number of participants. Okay, to represent the problem into a piecewise function, we have here C of P is equal to 500 pesos times P if the number of participants is 15 or below. So we represent 15 or below as P greater than 0 but less than 15. So they will pay 500 pesos each. Now, if the number of participants is between 15 and 30, meaning you have here 16 or up to 29 participants, so P is greater than 15 but less than 30, they will only pay 400 pesos each. So we will have 400 times P. And if the number of participants is greater than 30, so each participant will pay 350. So you have 350 times P. Now, how much will the instructor earn if he has 10 participants? So since 10 is less than 15, so we will be using the first equation. So we simply multiply it by 500. So the instructor will earn 5,500. Now, how about if you have 25 participants? Okay, for 25 participants, that is between 15 to 30, so we will be using 400 times P. So you have C of 25 is equal to 400 times 25. The instructor will earn 10,000 pesos. And if he has 50 participants, since this one is greater than, the third equation is greater than 30, 50 is greater than 30, so we will be using the third equation. So multiply it by 350 each. So the instructor will earn 17,500 pesos. So this is how you solve this problem. This ends the discussion. I hope it is clear and you understand it. Please take note that it is important to first construct the piecewise function that will represent the problem for you to solve it. Kindly visit the Google Classroom for your activities. Thank you.